These are in listen-only mode.
Good afternoon and welcome to this afternoon's webinar provided by bobwillis.co.uk. My name is Bob Willis and I'll be presenting today's webinar. Before we start talking about our subject to today, which is solder paste printing and defects, I'd first like to introduce you to the control panel, which you have on your screen at this moment in time. The control panel allows you to do a number of things during the presentation. First of all, you can open and close the control panel by clicking on the orange button. This prevents it obscuring your view of the slides during the presentation. You can make the image on your screen go full screen, either on your projection facility in your conference room or on your PC by clicking on the button as indicated here by the red arrow. Now, at any time during the presentation, you can type a question into the panel here. Now, we'll be answering the questions, or I'll try and answer as many questions as I can at the end of the webinar. But please type any questions you have during the webinar, and I'll try my best to answer them for you. Now, if you have any technical problems, please use one of the telephone numbers provided on your registration and reminder emails. You'll also need your webinar ID number and access code, which was included on your email. It's not possible for the presenter to assist you during a live presentation. I may be good, but I can't multitask to that degree. Please remember also that the internet is still under pressure and you may have local speed issues in your area, in your factory, and particularly if everybody is watching YouTube at lunchtime. At the end of the presentation, we have a couple of survey questions. Please just take a couple of moments to give comments on the survey, its content, my performance, and the organization of this webinar. We really do appreciate your input. I will be sending you a copy of the slides presented in PDF format at the end of the webinar, normally a couple of hours after the webinar, but please check your junk folder just in case that's where it's hiding. But you should receive a copy of the file from me shortly after the presentation. Now, in terms of the inspection and defect guide, the photographic guide, that will be mailed out as and when it's released. And we're looking forward to mailing that in the next couple of weeks, we hope. So, first of all, I'd just like to thank my sponsors, or the sponsors who sponsored A, this webinar, and B, the photographic guide that I've produced. I'd like to thank them for their time, effort, and support to allow me to provide this defect guide in this webinar for you. So just a little bit about my background before we get into the topic of today, just to give you a reference to who I am and what I do. I'm a mechanical engineer by profession. I've been involved in electronic manufacturing all of my working life, in contract manufacturing, OEM, PCB fabrication, and environmental test and failure analysis. And I've had the great pleasure in visiting many countries, working for many organizations worldwide, providing presentations, both hands-on and theoretical. It's what I love, it's what I enjoy, and I consider I learn a lot from everybody I work with. Now, as well as this particular webinar, we have a repeat of this webinar coming up on the 26th of October. So if any of your colleagues missed this particular session, then it's repeated on the 26th of October. It will be live again, not a recording. You'll get the real thing, mistakes and all. Also, my regular monthly webinars in November and December, as listed here. And I will be presenting 2 3-hour workshops as part of SMTA International Conference and Exhibition. And that's coming up in a month or so's time. And I'll be covering robotic soldering and practical use of low temperature. So that's a little bit about me, what I do, what I enjoy doing, and hopefully maybe of interest to you. Now, I mentioned at the start, we've created, along with our sponsors, a booklet, a guide to solder paste, print inspection, and defects. And that color booklet as a PDF will be available shortly. You, as a delegate on this webinar, will receive a copy as soon as it's available. That will be mailed directly to you. And of course, it's going to be circulated worldwide. And I hope, if we have more sponsors, to be able to produce a lot more defect guides in the coming weeks and months. So that's just a little bit of an introduction. Okay, so let's get into our session. We're going to be talking about solder paste stencil printing, but I want to talk about some aspects that perhaps we don't talk about that much, rather than talk about the more obvious things. But first of all, just a little bit of an introduction. So when we're printing solder paste onto the surface of a printed circuit board, we start with a board and we print directly on it with a stencil. And a stencil may be 6/1000ths of an inch, 5/1000ths of an inch, 4 or 3/1000ths of an inch in thickness. So we're looking at 125, 100, or maybe 75 microns. And the stencil material vary. Stainless steel, very popular, but also nickel form stencils. So there's a variety of different stencil materials, and each engineer has to decide which stencil material is appropriate for his particular application. We then take the solder paste and we print it across the surface, and we use a squeegee blade to achieve this. So slowly we're drawing the blade across the surface to produce the print. Now the solder paste material is obviously available from lots of different manufacturers, and I have to say, in my experience, that the quality and consistency of solder paste today is pretty good. It's not like the old days. So all of the expert manufacturers out there provide good products. You've just got to evaluate which material gives you slightly better performance, better age, better price, better delivery, all the aspects you need to consider. Paste is a material which has to roll on the surface of a stencil, as you see indicated by the top right image. And it's got to roll across the surface, as you'll see in some videos later on, to get the best performance. The stencil must be clean. It must be well fabricated. It mustn't be damaged in any way to achieve what we want to do, which is a perfect print, which I show on the final image on this slide on the bottom right. Here you can see a reduced area print on an area array round pad, and that's pretty consistent in both position and volume. Now, solder paste materials are available from suppliers with different sizes, and up until recently, type 3, 25 to 45 microns, was the most popular, universally used. Now, type 4 is a very common material, which has really become the natural standard. And partly that is due also to the price. Originally, type 4 was more expensive than type 3, and possibly is in certain areas, but the price differential for the quality of printing is justifiable. So generally speaking, most people are using type 4 today on most applications. So that just gives you an idea. Of course, there are other pastes for other applications which use type 5 and type 6, but type 4, the most common for our printing applications. So to print, we pass the solder paste across the surface in a rolling action, applying force down through the aperture onto the pad, as we see indicated here by this animation. And then when the stencil separates from the surface, we get, hopefully, a perfect print. So in this example of me printing some defect boards, these are special boards I produced for X-ray and AOI investigations, we're showing the print stroke. And ideally, what we want to see is good separation. What we want to see also is a clean surface. We don't want to see any damage to that surface when we're going through the printing operation. So that's just a classic example of the printing process. So we've printed, we've placed paste onto the pad surface based on the design that you're going to be using. Now, as an alternative, sometimes companies will also do surface mount and intrusive reflow. And anybody who knows me knows how much a fan I am of intrusive reflow soldering. Well, I wrote a book on the subject, which is free to download if you're interested. And this allows us to assemble through hole as well as surface mount in one operation. So this just shows you a classic example of overprinting during the printing process. And if we look closely here, you can see an example of the stencil I might have used and also the paste deposit. So Sometimes we print undersize, sometimes we print oversize. It just depends on the particular application and the product that we're going to be building in our process. Now, just to give you a different view, and I like to use this technique, and many paste manufacturers and also a number of printer manufacturers have used this particular technique to understand the print separation process. So this video clip just illustrates the print into the apertures and the release of the stencil from the surface of a sheet of glass. This obviously is not a PCB, but it's a surface which is flat, parallel to the stencil, so we can see the performance. So here we've got some perfect prints on the surface of the glass. Now, this technique, as I said, has been used by a lot of companies over the years to understand more about the printing process and also the materials and how they perform. But it's useful to understand and also to train people what's going on in the process, which I like to do. Now, we said a perfect print, but what's a perfect print? Now, back in 2001, I wrote a standard, a solder paste inspection standard, and it was purely because I had to do that for a PPM monitoring project that I ran both in the UK and Europe, where companies compared their PPM yields, their defect levels. So I had to have something that people worked to. And I'm not saying this is right or wrong, it's the standard I produced at the time. And you can read through the criteria at your leisure, but basically we had a satisfactory print, an acceptable print, which didn't require rework and repair, but correction of the process, which is not quite as good as the perfect print, and unacceptable, where we had to not accept that print for the build of the board. And we included different examples of termination. So what I show you here is satisfactory printing on chip components, area array, and QFN packages. So this is just an example, but it illustrates the basic criteria I would use for a satisfactory print. Of course, you may be able to improve on this. You may have slightly different design apertures on your particular boards, but fundamentally, it's a good print. Here, we see what I would consider an acceptable print, where the paste is misplaced, but it's less likely to actually cause a manufacturing problem. So the key thing here is correct the process and make the product better, but don't rework the product in this particular case. We all know how difficult it is to clean off a board. So if you can accept boards that are slightly misplaced, then that's fine. You'll notice I've put some percentages in, and this is what I put in at the time of writing this particular document. You'll see that IPC standards have a slightly different criteria, and of course you can change it if you wish. But this is where I started off in 2001 with using the 80% 20% rule. And again, you can adjust this for your particular product. And I set unacceptable where there was a misplacement or a loss of print which was greater than 20% of the surface area or the print area of the aperture. So that's basically a simple inspection criteria. And these inspection criteria are available separately on wall charts if that's something that you're interested for training within your organization or company. So let's just for a moment look at some of the reasons why we get defects. And I may, if I've got time, will run a poll a little bit later on during this webinar. But what I wanted to do is just show you the results of a previous poll on common printing defects. And if you look at this example, the greater majority of engineers, there were around about 100, said that misplacement or misalignment of prints was their biggest challenge. And I can understand that because the variability we can get with the PCB, regardless of whether we use fiducial optical correction, because if you've got boards in a multi, then your fiducial correction can only give you the best fit, not a perfect fit. particularly if there's differences in position of each of the individual boards within the multi. So paste misalignment, and certainly on big boards, is a problem within our industry. But we're fighting the limitations of some of the materials we use today. I also asked the question, what contributes most to your printing defects? And the engineers at that time unanimously said, well, 41% was stencil design. But stencil design, we have a benefit when we have stencil manufacturers taking our data and producing stencils. And quite often they make recommendations, and they are seeing hundreds of thousands of stencils on a weekly and a monthly and a yearly basis. So if you get some feedback, some suggestions, then consider it and look at what they're suggesting, because they're seeing a lot more stencils than you ever do in manufacture. So again, I'm not saying accept it, but look at it and consider their suggestions, because those design tricks can really benefit the quality of printing. Now, I visit a lot of companies, and I do get frustrated sometimes that people don't do first off prints. They may do first off prints on production boards, which is a bad thing, because you've got to clean the board afterwards if you're unhappy. So by using tacky film, as I illustrate here, it's a simple, cheap and cost-effective way to look at the quality of printing before you actually contaminate the board. So you can get this thin, tacky film from a variety of suppliers. I'm sure if you do a search online, you'll be able to find these. And you can use these as a method of doing your first off, your production approval to start production. And also, you can actually use it for measuring the paste deposit on the board as well. That's one way of doing it. There are others. And what I would suggest, a better way of doing it, is print onto the actual board, but not as part of the production batch. Just like we get a board for reflow soldering to set up our oven, why not get a board to set up your printer? Now, if it's a board which has got a good surface finish on it, like nickel gold, like a solder coating, you should be able to use that board time after time after time, cleaning it properly, of course, but then that guarantees you're printing an exact replica, hopefully, of the board you're actually going to be doing in production, proving you've got a good print before you move on. That's another option. But if you want to use the sticky tape, then that works fine. And I've used this in military contractors, medical contractors, so it's not just for consumer electronics. So basically, we put the board upside down on the film, cut around the edges, leave some film on the edges to allow us to pull it away, to lift it up, to peel it away from the board when we've finished. We can then inspect the results. But the first thing you want to do is make sure that when you apply the film to the surface, you don't want any bubbles in place, as I indicate here with the yellow arrow. You don't want anything to lift the stencil above the surface of the print area, because obviously that will give you poor performance. So take care. So these are just a couple of examples of, first of all, poor printing. You can see, and this is on the surface of the film on the right-hand side on an area array package, and on the right-hand side on a QFP. So again, it's simple. You print, you see the defect, but it's not contaminating the board. Next example, top right, you can see misalignment. We've got consistent paste volume and consistent printing, but it's misaligned. And this may or may not be outside your own specification. Bottom right, again, another QFP, you can see it's misaligned both in one direction, which is effectively taking it off the pad in two directions, as you see. But again, this would be unacceptable because the pads on the right-hand side of the QFP are actually touching with the solder paste. So that wouldn't really be acceptable to most standards. And if you get incomplete prints, as you see in this example, on a through-hole soldering application where the solder paste hasn't covered the complete pad, then again, if it doesn't meet your criteria, then you're going to set up and make a change to your process. And after you've finished and assessing the results, you peel off the film, and then the board can actually run in production. So you've got two ways of assessing the quality and consistency of the printing process. Now, wash-offs in the real world happen. In the real world happen. Ideally, you want to avoid them. But if you are going to wash off a board or boards, you need to make sure the cleaning material you're going to be using is compatible with the solder paste. It's just like cleaning of flux residues. You want the chemistry to work with the paste. Sometimes materials are not compatible, so you're mechanically removing the material. Obviously, you're mechanically removing the solder alloy, the actual particles, but all the fluxing materials, what you want them to do is to go into solution, so you're proving the material is compatible. Your cleaning material or chemistry must be compatible with the board as well and not affect the wettability or solderability of the board. If you look at copper OSB, that can be affected by cleaning agents, so be aware of it. You need to look at the cleaning methodology. Now, a lot of people manually clean. Some people use manual but assisted ultrasonic cleaning, and some people use batch cleaners. You've got to decide what's appropriate for you, your company, your operation. But one also important thing is you must monitor the frequency. You don't want your screen printer operator, because of some frustrations with the quality of boards or the stencil, having to print and then clean off 50%, 10%, or even 5% of the boards he's processing. So you need a check, not as a check on the quality of the printer operator, but a quality of the problem. And it's good practice to keep a log of how many boards you're washing off. I also recommend you mark boards. So if a board is a production board and it's been washed off, put a mark on the scrap area, on the breakout section, or just on the edge as I show here. And the reason for that is traceability. When you're through production and you're right at the end and you're having some process issues, you want to be able to analyze those defects possibly. So again, knowing the board has been through a different process to everything else is a valuable tool for failure analysis engineers like myself. However, normally speaking, I can spot a washed off board, normally speaking. But again, that's what I would suggest you do. Now, AOI, Automatic Optical Inspection, has been a technique which has been introduced by many companies over the last few years. And although you can do manual inspection, you can do manual weight gain, you can do mechanical measurement of solder paste deposit, that's old school. It's things that we were doing 20 years ago. You can still do it, and it gives you some degree of confidence, but really in today's modern technology, automatic optical inspection gives us so much more to be able to gather data. But please use the data. There's no point having a machine producing data that you don't actually consider and use. That's what data's for, to utilize it. So just as an example, what a typical AOI, automatic optical inspection system, an SPI system would do is produce some data. And I'm just showing you 3 examples of some studies that I did a couple of years back. And this is on solder paste volume measurement on 01005 pads. These are the small resistors capacitors, and also height measurement. And I'm not saying this is good or bad, I'm just showing you an example. And what you're looking at here is on a 3 thou or a 75 micron stencil. And on these, this is an 0201 using a 4 thou 100 micron stencil. And this is just a height measurement. But solder paste measurement can be a very powerful tool to pick up defects. And I'll show you one defect that was shown up and embarrassed me, I have to say, a little bit later on. Now, I mentioned that IPC has some inspection criteria, and again, you can decide on what numbers you might use, but the IPC 7527 is a document that was released a couple of years back, a lot newer than the document I originally wrote. But this document talks about setting standards for target, process indicator, and defect. And you'll be familiar with this terminology because obviously it's used in other standards, and particularly IPC 610. So if you look at this, nominal height is the stencil would equal the stencil thickness. and a process indicator, so a variation on the process, would be less than that, but a minimum of 75%, and so on. So the IPC standard breaks it down into target, process indicator, and defect class for each of the different levels of IPC. And if you look at the document, it's fairly well illustrated with both graphical examples of the common defects, which is misalignment, incomplete print, contamination, and other things that the document goes into, which we won't go into now because you can review this for yourself. But it talks about all of the different areas that we've got to consider. A lot of stencil printers produce inspection data, and that's obviously the area of coverage, but it's the SPI which gives you the volume information as well as consistent height measurement. And that's why there's been a trend to use SPI on more advanced circuit boards today, rather than just the area of coverage that we would generally do during optical inspection. So in terms of the targets, again, I've got a couple of examples I've taken from the standard for you. Paste deposit is centered on the center of the pad. Paste deposit appears as one single block unless segmented by design. As you know, designers and process engineers design slightly different prints depending on what they're working with. And if you go through the standard, you'll find it broken down in this way. And of course, defects for misregistration of paste. So it's useful to look at the IPC standard and compare it with what I've said on my documentation. And again, here is some requirements for paste slump. And this term of slump and bleed and solder balling we'll talk about as we go through this webinar this afternoon. So let's start to talk about some defects, and hopefully I will be able to illustrate some of these defects for you. Now, I just want to say right now that the quality of solder paste, as I've said a couple of times already, is pretty consistent from the suppliers today. You all know the major suppliers within our industry, and all these guys supply good quality, consistent paste. But if you compare paste A with paste B, paste C, paste D, you will find that one possibly is better at one thing than another, and an engineer will select a paste for his particular application, his particular process, or possibly because he's going to clean the product, or possibly because he's going to conformally coat over residues. So there's a wide range of requirements, but let's pick up on some of the sort of common things we do see which can cause us an issue. Well, paste slump is one. Now, when a paste is produced, we print it onto a surface, and what we don't want it really to do is slump. We don't want it to spread out, because as you see here, all of the individual apertures or paste aperture fills have drawn together. They've slumped. They're just like butter on a hot day. Now, a good quality paste won't slump to this degree. And although we print a paste and have a hold and weight, it certainly shouldn't slump, but it may well slump as it gets up in temperature. So when it gets close to reflow, but before reflow, ideally you don't want it to slump either, because there's always the possibility of a short circuit forming. Now, as you understand your process and the thickness of stencil you're applying, a stencil of paste you're applying to the printed circuit board, you might actually find that some paste deposits that actually do slump don't short. And that's great, but you need to know your process. So slumping is a poor characteristic of a paste. It can occur. It can also occur because of the profile you're running for your particular product. So always look to see what the vendor has recommended in this process. So this is just a quick example of a video clip showing slumping. And what you're looking at is the paste slumping as part of that reflow process. So one of the things you can do to evaluate slumping and in fact bleeding of paste is to use a test stencil. And a test stencil, quite often available from paste manufacturers, but certainly the design is included in IPC and other standards. And this is a test stencil that you might use on a ceramic plate. This shows print, and you can use it for print slump, but also solder balling. So it's just a nice stencil. There are other stencils you can find online, and of course your stencil manufacturer may be able to supply some samples for you that you could use for this particular testing when you're evaluating new pastes from suppliers or new products. Now, this is paste slump, but also it's solvent bleed. So when you're printing, what can happen if your stencil is not in good contact with the PCB, or if the stencil is in good contact, you can get capillary of some of the solvent from the solder paste. And what that then can do is allow particles to bleed between the two prints, as you see here. So this is just an example. So when you're evaluating pastes and printing, you've got to look at high magnification for the quality of the print. And of course, this would be able to be acknowledged or seen using SPI inspection, where they do three-dimensional maps which can show you paste deposits on certain pitches on a board, and a very useful exercise to consider. If you look at this example, these are two experiments of mine when I've been looking at bleeding. So this is the solvent or the vehicle bleeding away from the paste which has been deposited in the apertures on the surface of glass. So I've printed these onto glass and I've looked at the whole cycle, but these are the end of the cycle, so you can actually see what's happening and the wicking effect that's happening on these large pads and also on these fine pitch areas. And if we look at this video clip, again, I'm sort of representing the same thing. And as I pull back the stencil from the surface, you can actually see the paste and paste particles have started to wick together. So some of them are touching, but certainly there is material sitting on the glass surface between those paste deposits. So doing a comparison between prints and this print simulation, if you like, onto glass is a useful tool, and it can be very representative of what you're actually seeing in production. But using video photography, as I've always said, a picture's worth 1,000 words, a video's worth 1,000,000 words to understand what's happening in the process when you're comparing materials and process and, of course, yield. Now, incomplete and missing paste deposits can be printing. It can be contact to the stencil on the surface of the board, but more importantly, it's probably down to the aperture actually used. And this is a classic example, and I put my hand up. This is my fault. What we've actually got, and we picked this up with SPI on a line I was running with a friend of mine, in fact, 2 production lines in Sweden, where we've always got a couple of pads that had no paste on it. And you can see one of them clearly seen here. And the SPI picked this up, identified the position, and it was my fault for not checking the stencil supplier's check plots. You know those pieces of paper, those emails you get, those annoying emails you get from the stencil supplier asking you to approve something? Well, sometimes you miss it, sometimes you don't respond, and this is what can happen. So immediately on the first day of this exhibition that I was running these production lines, we noticed the problem. I contacted the stencil manufacturer, and day 2, there were 2 new stencils there, and all we did was open up the apertures. So we actually slightly overprinted the pads, and again, the print quality, consistency, and the yield was significantly improved. And we can see that on all the different board finishes we were running. This is obviously a tin lead sole level board, but we also saw it on other finishes as well. So again, use the information, use the knowledge of the supplier trying to help us out, never not pick up on check plots. And also, if you're a contract manufacturer, please check the stencil information you get from your customer. I get this a lot as well, where contract manufacturers say, well, it's not my responsibility, it's the designer. Well, who's the expert in printing? The contract manufacturer. So please check the information, and certainly check the check plots that you get back from the stencil manufacturer if you're a contractor. If you want a good, easy life, it's one way of achieving that. Now, solder balling, I would say, from my experience, is quite uncommon today when you're evaluating solder paste. So when you're testing out paste, the performance of the materials is so good and so consistent. It's quite uncommon. However, where you get new products, new materials, then quite often you might see variations in their performance. More recently, in the last couple of years, I've been doing a lot of work on low temperature alloys, bismuth containing alloys, and I have noticed that if I compare products, I do see some evidence or more evidence of solder balling during reflow tests than I do on traditional products that we'd be using today. I'm not saying this is going to be a showstopper, but if you're evaluating A, B, and C, and you get solder balling on B, you're going to use paste A and paste C. You're not going to use paste B. That'd be one of the sort of factors that you consider in your choice. So again, doing solder balling tests is old school. Yes, you don't normally see problems with products today, good quality products today, but when you're evaluating something new, understand its capability, what actually might cause some issues during your evaluation. And it's also the same on solder particles. Now, back in the day when we very first started SMT, a lot of companies spend a lot of time evaluating distribution, size of particle. And I'm not saying that's not right to do, but I'm just saying the quality and consistency of solder paste, generally speaking, is pretty high. But I do always look at particles and particle distribution and look for variations when I'm looking at something new that I've never seen before or never evaluated before. So in this particular case, we're looking at some tin bismuth silver paste, and I had 3 or 4 different suppliers to look at. And I was surprised at the variation distribution on size, and also I was surprised at the variation in shape of some of the particles. And I felt personally it was outside of the standards that a lot of companies work to today. So I'm not saying that you're going to suffer this or see this, but it's something to be aware of. And perhaps when you're trying new materials, new technologies, new particle sizes, so going from type 5 to type 6, just look at the technology, understand the technology, and is it significant or isn't it significant to you? But these are just some examples of my own experience that I've found. Now, another thing that is something to be aware of, particularly if you're a no-clean company, we don't want spitting. Now, this is spitting of solder particles or even spitting of fluxes. And this is a test that I quite often do if I know I'm working on a medical product possibly, or a medical product where it's a no-clean product. I run solder paste and reflow it, and I put it under a watch glass, a laboratory watch glass. And what I'm showing you here is a video clip which allows you to see spitting taking place from the paste material when it's in a liquid state. So you can see the little droplets forming on the hourglass, which is above the surface. Now, again, we get evaporation from paste. There are volatile materials come out, but we don't want this spitting because it's going to spit out over the surface of the board. And it may or may not give you a problem with your process or your material. So again, it's something to understand. The key thing here, obviously, is experimenting at the temperatures advised to us by the supplier. So getting the profile right to evaluate what's actually happening in the process. So very important. I included this as a defect with paste, and I know it's reflow and not printing, really. But it's something that I have seen on 2 or 3 occasions just recently on small chip processing. It's something that people used to refer to as graping, and there have been a number of other terms related to it. It's basically the paste has worn out, the fluxing medium has been exhausted before the solder joint has actually been made. And the end result is these lots of little balls held together, and they actually sometimes make a perfectly good solder joint, but they just don't look right. But it's again related to the paste material and its compatibility with the profile you're using, particularly in air. these two examples are very small parts that I was processing back very early on in lead-free technology days, but I just thought I'd include it. And again, there's a little bit of a story behind that particular defect. So we've got our stencils, we've either printed successfully or haven't. We've looked at the quality of print, consistency, and hopefully everything is working well. So cleaning of stencils. Stencils have to be looked after. They are precision tools. I can remember many years ago, a friend of mine getting very concerned and upset when he bought his very first laser cut stencil at $1,000 or $1,200. And somebody damaged it. So he was really, really upset. So they are precision tools. You've got to look after them. So you've got to clean them. After the printing process, or possibly when you're having defective printing, you need to take it off and clean it before you try and reuse it again. So you've got to look after it. So whatever procedure you use, you've got to guarantee that it's giving you a clean stencil. There's no residues on the surface, both top and bottom, and all the apertures are perfectly clean. You must make sure that you select the right cleaning chemistry, but that's down to you because you know what paste you're using, what machine you're going to be using. So whatever technique you use, you've got to assess the materials based on that type of technology. So manual cleaning works and can work. It's not the ideal, but it can work. And I've got a procedure which I use for cleaning stencils manually and semi-automatically, and also inspecting the stencils afterwards. But the first key thing is making sure that you clean the stencil. So first of all, you take off as much paste as you can prior to trying to clean it, and that's both sides. And by cleaning one side and then cleaning the other side, you can collect a lot of the paste residue on an absorbent material which is underneath the stencil when you're cleaning it. So although you're cleaning on the top side, you're forcing material through the surface and it's being picked up on an absorbent cloth or some blotting paper or something of that ilk underneath the stencil during the cleaning operation. So that's sort of one methodology, if you like. And then you've got manual but ultrasonic cleaning. And there's a couple of suppliers of this type of equipment out there. And what we're doing is introducing solvent to the stencil after you've cleaned the majority of solder paste off of the stencil. You're not starting just from, as soon as you've taken your paste to reuse on another job off, you take the majority of it off again with a squeegee blade, but it's just taking it and cleaning the surface and removing it from the apertures. So this is just an example of ultrasonic handheld tools. But again, the chemistry you're using needs to be right for the process. And this is Bob Willis, myself, the author, actually doing cleaning on a production stand at Productronica, one of the largest shows in the world in Germany. And I was doing this at a production show, and I was cleaning the stencil. And as you see here, again, my trick video. So you're looking at me looking through glass during the cleaning operation, which is useful to understand your process. So you're manually cleaning that, and then finally going over with a wipe, which may be a dry wipe, it might be a wet wipe, depending on the chemistry and process you're going to be using. So when you've done that, the key thing is making sure that the stencil is clean, it's not damaged in any way. All of the solder paste is removed from the apertures. Now, a secondary process you could use, but you only use this when nearly everything is off the stencil. So the stencil is intrinsically clean, but you can use sticky rollers. And really this takes off fibrous material and fibers from apertures, because remember, these apertures are quite sharp and they can easily catch fibers. So again, rolling over with a sticky roller, as I illustrate in this example, first of all, and then transferring it to a tacky sheet allows you to assess, or not the case, whether there is any residues on the surface. And these tacky rollers tend to be used on PCBs to pick up fiberglass residues or fiberglass resin, and can be used as part of an inline process. I know the automotive manufacturers are very clean on the cleaning of printed circuit boards prior to going through the printing process, but this is sort of like a manual version of that. So that, again, a technique to be used. So what we should achieve is stencils that are absolutely perfectly clean, not like the examples I show here. So if you look at this example, you can see that we've got quite tight apertures. Some are on QFN, some on through hole, and some finer pitch on the bottom here. And again, you can see material hanging up. Now, if you print and you don't get 100% release on a stencil during the printing process, then this may be dislodged onto your next print, and you might get a perfect print. But if these are stencils which have come out of your cleaning rack, your library of stencils, then this is bad practice, because those particles have got no flux left in them, probably, and you're adding solder paste volume to a joint, possibly, when you print, and you might have an issue with the amount of flux available to reflow that volume of paste. That's a possibility. You've got to think of everything when you look at defects. You know, what could go wrong, and has it affected the print and obviously the reflow cycle. Now, in terms of stencil inspection, I certainly recommend that you check your design files against the product when you receive it. Now, stencil manufacturers do their own quality control checks, looking at stencil, looking at apertures, doing measurements. So they do stuff like that. They do have their own AOI, automatic optical inspection systems, for stencils. Not all, but some companies do. You should look at a stencil when you receive it, check it, and you'll obviously check the design was right against the design data. You may offer it up to a light box to see that the condition of the stencil is good, and make sure that it's not damaged in any way, and look for any damage or kinks in the stencil. After the stencil has been used, the production operator would clean it, check it again, possibly using the light box to make sure it's perfectly clean. I normally look for the four corners of the stencil and then the finest pitch on that stencil. I'm not saying I don't look everywhere, but I mean, you know, that's what I would normally do. Four corners and the finest pitch. And that gives me confidence whether my process, whatever technique is being used, has achieved a clean stencil. And then I return it to the rack for reuse. And if you then check it again when you put it onto the stencil, onto the printer, you know, you've got sort of two checks happening, which minimizes the possibility of a stencil being used that is damaged and inappropriate for production use. Again, you can collect other information on stencil usage, you know, damage, and have backup stencils. But generally, backup stencils is a thing of the past, because you can get a stencil with a quick turn now, certainly within 12 hours. It will cost you more. Some high volume companies will have a backup stencil. Again, that's, you know, your own engineering decision within your organization, what you might want to do. So just have a look at some stencils first of all, and sort of some damage, quite significant damage. The top row, the middle and the right examples are damage, either during use or possibly even cleaning. And that would obviously have an impact on the quality of print and the amount of paste going through on the right. The one example on the left-hand side is a laser cut stencil, where there's part of the piece of metal which has been cut out by the laser and hasn't been removed. And that is the only one I have ever seen in my life like this. I'm sure stencil manufacturers and some of you on the webinar may have seen some, but that's the only one I've ever seen in my life. And it was with my good friend from MPM. We were doing some printing trials, and we found this when we were actually doing work. So it's unusual, I think, unless of course you tell me differently. Now, here are the more subtle defects, if you like, where we've got slight deformation of the stencil surface. But these kinks are sufficient to impact the consistency and quality of printing. So it's your call on when you replace a stencil, but clearly if it's affecting the quality of the print, consistency of the print, and being picked up by your SPI system, then really you should be getting a new stencil or picking it up. Now, moving on a little bit, understanding paste material and how it reacts when you print it, the size you print it, the volume you print it. There are different techniques that we can use. And I've been using for quite a few years video simulation, and some of you may be aware of some of my experiments. And with video simulation, you can obviously look at printing, as I've done on glass. You can look at printing where you're separating the stencil away from the board, and some well-known stencil manufacturers and other manufacturers have done this work, and they've produced some amazing videos to understand what's actually happening. I've seen them, but I've never been allowed to use them, but they are absolutely gobsmacking. But that's why I like to make my own as well. But reflow video simulation can be used for paste and paste evaluations. I just wanted to share with you a couple of examples. And the first example is using video simulation but in X-ray for pin in paste. And what you're looking at is paste in a hole, but also on the tips of the pins. And as it's watching reflow all the time, as you're going through the process cycle, it gives you an indication of the amount of voiding that's taking place, whether one paste is voiding more in a plated through hole than the other. Now, equally, you could take the board and look at it after reflow and look at voiding, which is taking place, but you can actually see outgassing. So PCB outgassing or via outgassing. So video simulation, again, just gives us those extra benefits. And here's just an example, a simple example of paste reflow on an area array package. And you can see the ball and the solder paste realigning together. So again, you could look at separation, whether a water-soluble paste pulls back parts more readily than no clean material. So there's lots of things we can use video simulation to understand the process, duplicate possibly defects that are occurring, and hopefully overcome a process problem. Now, I mentioned on a couple of occasions the use of intrusive reflow, and you probably get the feeling that I kind of like the process. And this is just an example of a production line I was running, again, a product, no, it's electronica on this particular occasion. And I was trying to show how paste drips off of pins as it goes through reflow, particularly if you've got a large volume of paste. And just, you can see here how one paste performed not as well as others on some of the testing. And you can see in the oven, at the end of the oven, you can see these blobs of solder, and that's solder which is dropped off of the board from out of large through holes. And to show this up, what I also did is took a piece of copper foil and ran it through reflow underneath boards, and you can see again the solder has dropped off the pins. But these are quite large holes in this particular experiment. So again, it's just giving you ideas, tools to be able to understand your process a little better. In this video clip, I just show something that was shot for me by somebody, a friend of mine. And this is, I think, one of my test boards. And what we're looking at is a 100-pin connector using intrusive reflow. And you can see the paste pull back along the pin into the through hole to give us 100% fill. And understanding the wettability, how material reflows, how it exits, how it is lost in the reflow process is something that we can benefit from when using these types of technique to assess. So solder paste, I haven't mentioned so far, but of course solder paste storage is something that we need to consider. And I produced a series of charts which talk about solder paste and storage. And again, you can see a copy of these when I send out the slides, but each different paste manufacturer will have recommendations. So let me just go through the fundamental things about paste. The fundamental thing is when you receive paste, it will be in a container from your supplier. First thing, when you're going to be using paste, you take it out of the storage container and put it into a fridge to extend the life. That's what it's there for. When you've taken it out of the fridge, you allow it to recover for the time necessary. So there's no condensation into the pot when you open it, so it's at room temperature, and typically it's sensible to take paste out of the fridge overnight. So you take it out, it's ready for the next production, or you take it out the shift before, so the next shift has got the paste ready to run. Paste should be stored correctly in the fridge. Of course, some manufacturers have cassettes, some have tubes, some have jars. So again, the jars are pretty straightforward. Tubes, quite a few manufacturers recommend tip down. And again, when we're talking about the cassettes, quite often it's mounted flat, the way you would use it on your printing process. When you take paste out and it's got up to room temperature, it's recovered, you've used it, if it's still printing satisfactory, it's good practice, possibly to reuse it on the next job. You just transfer it from stencil to the next stencil and then into the machine, provided it's still printing satisfactorily. If you're going to take it off the stencil and use it, you put it in a used container ready for reuse. You do not put it back in the fridge. Paste that's out, ready for production, it's ready for production. So even if you're not running production for another 4 hours, don't put it back in the fridge. It makes no sense. It's long-term storage. You get a benefit from fridge usage. So when you've got your paste out, you either do a kneading stroke on a printer, or you mix it within the container, which you can't do with cassettes or tubes, but you can do with a jar of paste. So that's the basis of what you do, but each different manufacturer may have slightly different recommendations on paste, so it's important to understand what they require. And of course, more recently, some manufacturers have paste that don't require fridge storage at all and give you all the longevity of a paste without doing that. Right, let's just take a couple of surveys. So what I'm going to do is I'm going to post a survey, and what I'm going to do is get you to complete the survey. It's basically 4 questions, or 4 answers to a question. And what I will be doing is supplying you the information based on the results of this survey in the next couple of weeks when I've put it all together. So basically, I'm launching a survey, and this is on stencil thickness. What is the primary thickness of the stencil you use today? So what's the one that's most commonly used in your production facility today? And I'm going to wait until we've got at least 90% of votes, and then I'll move on to the next question. So if you just like to select which stencil is the most common you use in production at this moment in time. And by looking at this information, this is valuable to you as an engineer when you look at the results of the survey to get a feel for what other people are doing and trying to understand why they're doing it, and are they actually getting benefits from it. So we're over 90% now, so I'm going to close this survey and I'm going to move on to the next one. So the next survey question is, what stencil type do you most commonly use? What stencil type do you most commonly use today in production? So you've got 3 examples: etched, laser cut, or electroform. So etched, laser cut, or electroform. So 3 different stencil types. We're up at 70% votes so far. We'll stop when we get over 90. So that's 85%. Just a couple of more votes. So we've got about 99 people online. So it's a very representative assessment. So we're over 90 now. So I'm going to close that survey and move on to the third one. And this is, what is the most common solder paste defect during printing that you have or see? So what's the most common defect you suffer from during the printing process? So you've got misalignment, missing incomplete paste, solder paste bridges, uneven paste deposit, or under stencil contamination. Well, we're doing well here. This is rushing up to 60%. People have voted, so keep jabbing the screen. So we're up to 70%. So we'll stop at 90 just to make sure we've got a fair representation of the 99 people that are here. Couple more, and excellent. Okay, we'll close there. We're over 90%. And finally, the final question for you is all about what the cause is. What do you think are the causes, the most common causes for your solder paste printing issues? Hopefully not what I've said previously. It's what you think are the most common reason for solder paste printing defects. So we're up at 60%, 65, 70%. Well done, guys. You're doing well. And I use the term guys both for ladies and gentlemen, so I'm not leaving anybody out. Okay, so that's 85%. Okay, just a couple more. Okay, that's 90%. That's excellent. Okay, so I'll close that. So thank you very much. That's 4 different survey questions, all relative to you know, things that we talk about, or the things that issues that we have. And you'll be receiving the results of that survey in a couple of weeks when we've done the other webinar as well, just to give you feedback, some reference information. So let's just talk about inspection, or let's talk about standards for a moment. I've listed here for you all of the IPC standards, and I've also mentioned the NASA workmanship standard, and there is a section on solder paste printing and jetting technology, well, dispensing technology really. So you've got stencil design, cleaning of stencils, requirements of solder paste, and general requirements and test methods of solder paste for the J standard. So those documents are all available. You obviously have to pay for those. The NASA standard is available as a search. If you search it online, you'll find that. And I've produced my own inspection criteria and in training posters, but also my photo library. I have 23 photo library albums with over 300-400 images, which are great for training. You know, people use them as training and education tools. Now, as well in the industry, you've got 3 books that specifically cover solder paste and reflow technology. The first one, Ning Chang Lee, he wrote a book on troubleshooting a few years back, and that's very, very good and useful. Jenny Wang wrote a book specifically on solder paste technology for surface mount and other applications. And quite an old book by today's standard, Colin Johnson, who used to work, I think, for Alpha Metals, he also wrote a book. You won't be able to buy that online. You'll have to find it in a second-hand bookshop. But if you're interested in books on paste and reflow technology, those are very, very useful. And the book that I wrote on pin-in-hole intrusive reflow is available. It's free of charge. It's about 150 pages. A lot of engineers think, how could anybody write 150 pages about intrusive reflow? Well, there's a lot to it. There's a lot to the process. It's not quite as simple as some people make out. So what I've done in this webinar is talk about solder paste inspection. I've illustrated some defects. I've highlighted some of the things that really you should be looking at, in my opinion. And what I want to do is take some time out to answer any questions that you might have. At this moment in time, we've got about 6-7 questions that are on the list, and I'll go through those in a second. But just a reminder that I hope, as I said, within the next few weeks, our solder paste and print inspection defect guide book will be available. It's about 40 pages. I think it's about 30 or 40 pages when it's been typeset. And I just want to thank our sponsors, A, for sponsoring this webinar, allowing me to do this, and also allowing me to spend some time putting a book together on solder paste defects. I really appreciate that. And that was organized by What's New in Electronics. So again, thank you to the sponsors for doing that. And I'm looking forward to writing more defect books and creating more of my demonstration videos, hopefully, which might be useful for engineers to understand how process problems occur. So again, that's something for the future. But once again, I really do appreciate it. Okay, so we've had a couple of people on the call. Well, first of all, there's a couple of people say thank you very much. That was good. So that's good. Please fill in the survey when you leave. I like to know the negatives as well as the positives. What are your recommendations on underboard support? What is your criteria for when to use underboard support? I think really with any board that goes below 1.6 millimeters thick, so when you're going down to 1 millimeter thick, you need underboard support. I think there is a benefit with ultrafine pitch with underboard support with 1.6 thick boards as well, but that might be a simpler approach. You might be looking at individual tooling pins, etc. But if you use tooling pins, whatever type or style which are available from different stencil manufacturers, different printer manufacturers, the key thing is putting them in the same place all the time. Now, of course, some of the fancy printers put them in place for you. Some of the manual ones, you have to do it yourself, but they must be in the same place, exactly in the same place, time after time after time. So you need alignment plates or something to guide you to that position. Next thing is that as you go down in thickness of boards, then there is distortion purely by the pressure applied to the surface by the stencil and then the blade and the printing process. Then you need to perhaps think about other methods of support. And if you look in the industry, there are lots of different techniques that are used, and they do improve the quality and consistency of paste deposit. I would recommend it where possible, and again, it's just assessing which ones give you the best performance. What cleaning method is the best? Stencil cleaning, ultrasonic or manual cleaning? Okay, I have not found at this moment in time, ultrasonic cleaning to affect the cleaning of stencils. Now, I've done it manually, as you've seen on the video, and during that particular exhibition, I was doing this stencil. I was cleaning it. So, and I really didn't see any impact on it. If you're cleaning stencils in an automatic cleaner, you've got to think about, what sort of energy that cleaner is using, how close the jets are, as you say, to fine pitch areas. And if you're looking at 3,000 stencils, sort of 75 microns stencils, again, you want to be looking at the pressure and or the energy that's being used. Ultrasonic is a fabulous cleaning technique, and whether it's ultrasonic in a bath, which you're putting a stencil into, there can be a lot of movement generated. I've seen foils, very thin metal foils, put into an ultrasonic cleaner, and it rips holes in it. But again, that's the frequency. So again, you've got to think about, just like if you're cleaning printed circuit boards with components on, it's the frequency which really does the damage to components, nothing else. Next question. Regarding last question, you could... Okay. Yes, the gentleman just saying about with regard to maintenance of the machine. One of the key things with maintenance of a stencil cleaner is filtration. It's the filtration of the metal bits. And if you think about solder paste, it's quite expensive stuff. There's a lot of metal there, so I certainly wouldn't throw it away. I'd certainly look for some way of recycling it through a recycling agent, again with your solder paste. So the filtering and getting rid of the particles is something you need to consider, because that does impact the maintenance. Will solder paste go bad with excessive mixing? if you take a solder paste and mix it and mix it and mix it, and particularly if you mix it in one of these automatic mixing systems, it will change the characteristics of the material. So it won't make it go bad, but it will change, I would suggest, the viscosity of the material. And some solder paste manufacturers recommend using automatic mixers, and some do not recommend automatic mixers. So I guess it's based on their own experience. I personally have never used an automatic mixing system. I've just taken a paste, taken it out, allowed it to get back to ambient temperature for the appropriate time. I mix it manually, and normally for sort of 30 seconds, 40 seconds, just to make sure that there's no separation, and then I use the product. I normally do a couple of need prints, so test prints or need prints, and then I'm away. And if I've got a problem, I go back and relook at it. What is the best ideal solder volume for BTC thermal pads? It's a good question. It's not really the volume, it's the position of the paste. With BTC or LGA, QFN packages, if you get the paste positioning wrong or just get too much, you get too much volatile material underneath the package. The package then floats during reflow, and you sometimes get some open circuit joints because of that floating action. You will certainly get a lot more voids. So less is more on BTCs. I was working with a company only last week, and their print was a full print volume for the center pad, and that was recommended by the component manufacturer for thermal performance. Fine. I asked the company, do they need any thermal performance from this particular package? And they said no. I said, well, then put the minimum on you can get away with, because it doesn't help, it only hinders. So the thermal interface you're trying to build up to get heat out of the package, if you're not using that characteristic on the part, you're jeopardizing your assembly process, really. You're not actually helping it. So try and minimize the amount you're using on your BTCs. Break the area up, and I normally go for around a 50% coverage. And on most BTC applications, or LGA or QFN in my language, is normally with a 4,000 stencil. Best methods for specifying SPI criteria. I apologize, I don't understand that question. Perhaps you'd like to come back to me separately on that. Best method for specifying SPI criteria. So perhaps you come to send me an email on that question separately, because I'm not quite sure. Okay, another thank you. That's great. We have both wet and dry underwipe capability on our printer. Is it better to use wet or dry, a combination? I would say a combination. Again, this comes down to experimentation. If you're doing ultra-fine pitch, you're going to be cleaning the underside of your stencil more frequently than you will non-fine pitch. And you set a criteria. But I can't give you a number specifically, 5, 10, 15 prints or every print, because it's all about the paste you're using, the stencil contact with the board, the unevenness of the board. All those things affect what's your decision. So you'd start off with a number, and then what you'd want to try and do is reduce that number. So let's say you do a clean wipe or a wet wipe or dry wipe every some number of cycles, and then slowly decrease that, but compare the information with your SPI data or your other defect data. That's really the only way. And I'm not trying to avoid the question. It's just a fact that your process will be different from every other process. So really, you've got to start off with a number, and it's going to be more frequent, and then slowly decrease the frequency and find that crossover position. What is the effect of using incorrect squeegee size versus PCB panel size? Well, really, the squeegee, you should be printing where you're printing the apertures on the board. So let's say you've got a 10-inch board and the print area is 8 inches, then the squeegee blade may be just slightly larger than the 8 inches. You're not going to be having to necessarily print across a 10-inch surface. So again, it's thinking about what you're printing through. Certainly you want to be just large, just wider, or just slightly larger than the print area you're going to be printing. If you try and print with larger blades across a surface, you've got to have something to lubricate those blades, which is the solder paste. So you're moving solder paste up and down on your stencil for no value. It's costing you money to run, so that's not a good practice. So you're trying to get that size of blade appropriate to the print area on your stencil. How often should we clean the underside of the stencil during mass production? Same thing as I said before. You've got to start off somewhere. So every 5 prints, every 10 prints, and then change it. So you start off with lower numbers and slowly increase or decrease, because obviously the more you clean, the more that impacts on your throughput. And so what you've got to get is the process right. So I would respectfully suggest do a trial, and it's not going to take you a long time to do a simple trial to compare what print parameters that you want to use. Okay, Dean's also asked another question. I think I've already answered that one. Okay, what is the best cleaning profile to use for automatic under stencil cleaning dry wipe? Again, Hamid, thanks for the question, but look for or listen to what I said earlier. It's really doing some trials yourself. I mean, I could say to you, clean every 5 boards and do a wet every 6th board, and then every 5 boards dry. You know, you could have different combinations. You've obviously got to have a wet and dry wipes, and then possibly another configuration depending on your printer. But again, you've got to do those trials yourself. Is there a way to use paste exceeding suppliers' recommended stencil life? Of course, with the greatest respect to my paste suppliers. Of course, if a paste is still printing and printing well, and you're getting good print characteristics out of it, I do not see any reason why you can't continue to use it. If the quality of the printing is starting to deteriorate, you shouldn't be using it. So it's all about checking the quality. So it's checking the quality of the parts you're using in your process, just the same as any other material. And to do that, it's ideal if you've got SPI, because you know that's all that information is being generated for you every time you produce a board. If you've got to do it manually, it's a little bit more taxing, but just think about what can I look at on the board which gives us the best indication of the quality of print. Well, normally speaking, the smallest apertures, the finest pitch apertures. So look to those as your reference. So if you find that it's still printing perfectly and it's over the stencil life of the paste, then keep using it. But again, you're using the solder paste. You don't reuse it if it's not giving you the same sort of performance. That's the one thing. You do change. Is there any way to use paste? Oh no, I've answered that one. How often should I replace a squeegee? Well, it's about damage. A squeegee blade should perform, and just like a stencil, how often do you change a stencil? Well, you don't. It's only when the stencil is starting to give you a problem, i.e. it's damaged in some way. And if you do your quality control checks, it shouldn't be a problem. In terms of a squeegee blade, again, that blade mustn't be damaged. If there's any kinks in it, breaks in it, splits in it, for any reason, then the problem you will get is a problem during printing, or you may damage the stencil. Some stencils have coatings on which actually allow the paste not to stick to the squeegee blade. So sometimes you might find you're printing beautifully and the roll of paste that's there is actually picking up on the blade. Now, ideally, what you want it to do is not stick to the blade. You want it to sit on the stencil. So again, sometimes those release materials tend to break down, and that might be a reason why you might want to check it. Is the friction heat maybe generated during squeegee movement after solder paste? Is the friction heat maybe? Okay. I suggest the gentleman is asking, that's Shalab. I apologize if I'm getting your name incorrect. Is friction heat generated during squeegee movement? I've not actually seen this or experienced it. I've never seen this actually happen. So you tell me. If you get a infrared camera and try it out on your printer and run it up and down the stencil a few times, it's not something that I've been aware of or experienced myself, but I'd be fascinated to learn if you do some measurements. So all you need, go down to your maintenance department, ask them to borrow, if they've got an infrared camera, and check the stencil temperature, check the paste temperature, and then check the blade after you've printed, let's say 20 times, just as a kneading stroke, and see if you can see anything. I'd be fascinated to. You've piqued my interest now to see if there's anything there. Okay, so that's the end of all the questions. I've taken all the questions that you've posed. First of all, I'd just like to thank you for participating in this webinar. There is a repeat of exactly the same content of this webinar in a couple of weeks' time, just because there was such an interest in this webinar. So it won't be any different. The next one, it'll just be a repeat of. I'd like to thank the sponsors who have sponsored both the webinar, as you see on the screen, and also they've sponsored me writing this guide, and that's all been organized by What's New in Electronics. So once again, I'd like to thank you all. You'll be receiving a copy of the slides directly after the end of the webinar this afternoon. I'll be sending out the survey results a little bit later on, so it takes me a bit of time to work on that. And of course, it'd be a pleasure if you'd like to join me for a webinar in the future. I run webinars every month, and I do webinars on demand. So if companies want webinars specifically on a particular topic for their groups of engineers, that's what I do. So thank you very much, and good afternoon to you all. Good afternoon.